Thank you. As mentioned, I'm Chris Donaghey. I'm the Chief Executive Officer of Applied Energetics. Applied Energetics is a directed energy technology company focused on bringing to market a new class of directed energy technology based on ultra-short pulse lasers. The overarching concept here is that sensors are everywhere on today's battlefield, primarily cameras that are used to guide drones and other objects to their targets or to provide surveillance. And there's only going to be more of those over time. Therefore, a critical layer of defense, whether it's countering drones or in the broader Golden Dome application, will be the ability to take out the eyes of the things that are staring at you or want to do you harm, and that is largely what we'll be discussing over the next several minutes. First, our obligatory safe harbor statement. We'll be making some forward-looking statements in this presentation. But I like to begin this presentation with our vision statement. Our vision statement is directed energy anywhere. This is a bold vision statement. It's an ambitious vision statement because it's never been done before. All of the lasers that you hear about being used by the US military today are prototypes or experiments. There are no programs of record where the DoD is buying these lasers on a programmatic annual basis and deploying them broadly in multiple locations. Again, they're all largely prototypes or experiments. In order for this vision statement to become true, you have to have three boxes get checked. First of all, you have to have a widely proliferating threat that is vulnerable to the effects of directed energy systems. Small drones certainly check that box. Second, you have to have a directed energy system that is capable of delivering high-value effects that can neutralize those targets. Continuous wave lasers, high power microwave, as well as ultra short pulse lasers can check that box. The box that has never been checked is the ability to produce those systems in volume with the optimal size, weight, and power that allows you to deploy those systems in any location you want, whether it's mobile platforms from naval vessels down to the small side-by-side vehicles used by special operations, to deployed bases, expeditionary bases overseas, and even fixed sites such as military bases, power plants, and the border. That is the problem that we are focused on solving, that size, weight, and power problem, and that is what we believe will enable us to achieve this vision statement. So I'm going to start this with a little bit of a vignette, first of all. What you're seeing here, I like to call this my Where's Waldo chart. This is the Lockheed 60 kilowatt high energy laser mobile test truck versus our at scale Plaid ultra short pulse laser system, pulse laser air defense system. You can see that we have a substantial reduction in size, weight, and power on a relative basis. That also applies to cost as well. For the price of this Lockheed Martin vehicle, which does really cool things and may have a place on the battlefield, it's just hard to see this as a proliferated type of system. But for the same amount of money that you would spend on this, you could literally buy dozens of our systems and deploy those out to the perimeter of the facility that you're trying to protect. So the next vignette that you're going to see is related to the June 1st attack that the Ukrainians executed against the Russian airbase, the Belaya airbase in western Russia. So this is an image of that airbase. It's a roughly 14-kilometer perimeter around this airbase. And we have actually received questions from both partners as well as government customers. Hey, if the Russians had had your technology in place, would that attack have been as successful? So let's take a look at what it would have looked like. So here's the base. Here's what it would look like if you had deployed our system as kind of the forward perimeter of defending that system. You'd place 14 units, roughly 1 kilometer apart around that airbase. And all we can say publicly is that these lasers are designed to achieve a tactical range, which means 1 kilometer or beyond. So when you overlay the range of the system, you can see you have a nice overlapping field of fire around that Russian airbase. And so the probability of all of those drones making it through a quasi barrier like this is very small. If we can neutralize the optics on those small drones from 1 kilometer out, the pilot who is flying that drone has virtually 0% probability of hitting a target. If you can't see the airplanes that you're trying to strike, it's going to be very difficult to accomplish that mission. We won't say that we would be 100% effective in this particular case, but warfare is not about being 100% effective. It's not about absolutes. It's about percentages and dramatically reducing those percentages of success if you are defending a particular establishment. And we believe that if our system had been in place, we could have had a significantly positive effect on the defense of that system and greatly reduced the destruction that occurred in that time frame. When you include the drones now, so as drones are coming at you from multiple locations, a couple of things that you're going to hear me talk about is that our laser is capable of neutralizing targets in less than a second. So if I can take the eyes of these small drones out, if I can take the eyes of these small drones out at a range of 1 kilometer or beyond, again, the likelihood of them striking a target is virtually 0%. The other fortunate aspect is because we are such a quick delivery of the effect, I can afford to fire multiple lasers at individual drones to ensure neutralization of those drones before moving on to the next one. So the structure of the presentation quickly, what's the problem? We just talked about the problem. What's the solution? We've talked a little bit about the solution. Why are we the guys to deliver that solution? We'll talk a little bit more about that. And then ultimately, how big could the market be for these systems if we are successful? So we've already talked about the problem. Sensors are everywhere, and they're only going to become more prolific over time. Second of all, and I just want to show this one quick video because this is from the Balea Air Base, and this is what shows you that there is a pilot behind this drone. This is not an autonomous drone that is programmed to strike a particular aircraft in a particular location. This is a pilot looking to see what is my next target. That airplane's on fire. Okay, that next airplane just got hit by a drone. So this drone is going to keep flying until it finds a target that hasn't been struck yet. Again, if we can take the eyes of that drone out at a range well beyond the perimeter of the airbase, the likelihood of the pilot to be able to do what you just saw in this video drops to virtually 0%. And we're going to do this by focusing on ultra-short pulse lasers. So what does an ultra-short pulse laser do? Ultra-short pulse lasers take a low average power, we slice it up into many thousands of slices per second, and then we compress each one of those slices to a very small time frame. The intent here is to produce a peak power laser that is about 20 billion watts of peak power. And if I can get 20 billion watts inside the optics of one of these small commercial drone cameras, it's a pretty devastating effect. It kills the camera in less than 1/30th of a second. We're also building a family of lasers that will operate at multiple wavelengths, ranging from visible cameras all the way out to long-wave infrared cameras. When I can match the laser to the wavelength of the sensor, there is no countermeasure. Our pulses are so short and such high intensity that there's no way to stop it from creating the effect on the camera system that it's targeting. The last aspect of this is we are using a new type of architecture that is based on optical fiber, and that allows us a couple of things. Once we've developed the recipe for what that system looks like, it makes it easy to manufacture, and it's a repeatable process. And because it's based on optical fiber, it's relatively straightforward to ruggedize, and it also is what gives us the small size, weight, and power footprint of the system that we're able to deliver. The effects here, so at longer ranges or lower energies, you initially jam the sensor so that it can no longer create an image of what it's trying to see. The laser is saturating the sensor and it's blinded, but not permanently. If you increase the energy on the target, you start to do damage. Ultimately, you exceed a threshold where you're ablating the materials on the sensor itself, and the sensor will fail to operate, and it's essentially been destroyed. But again, and we do this effect all the time. We've been proving that we can kill cameras in our research laboratory almost from day one. The real innovation here is the footprint of the system that we expect to deliver this. So you can see this system is roughly the size of 2 shoe boxes. It weighs just under 60 pounds, and it uses about the same amount of energy from the wall as your garage door opener. 1,000 watts of power is a very low power system. Certainly relative to the continuous wave lasers that are being used in those prototypes and experiments that I was talking about earlier. So here's an example. This is the Locus laser that's was produced by a company that was called Blue Halo, now part of AV. It's a 20 kilowatt laser, but the main thing to understand here is that laser is 60 times the size of our system by volume. It weighs thousands of pounds. It's going to use about 100,000 watts of power compared to our 1 kilowatt system. So the system we're bringing to market has substantial advantages from a size, weight, and power perspective. It also will have an advantage from a cost perspective, and it is what will allow you to have this distributed or proliferated architecture that allows you to buy many of these things and place them as that outer perimeter of capability. So why are we the guys to do this? We've been doing ultra-short pulse lasers for a long time. As mentioned, 27 awarded patents. We actually have 11 applications that are held under government secrecy orders, meaning the content of those patent application is so sensitive that the government doesn't even want those patents published on their website, so they're held in reserve by a specific portion of the Patent and Trademark Office where they hold things like this that they don't want disclosed to the public. And we continue to develop new patented approaches. We have with 8 additional patents pending. We've been doing this for a while. Our chief scientist and Applied Energetics built a 5 terawatt ultra-short pulse laser back in the mid-2000s that demonstrated that you could affect sensitive electronics at pretty long ranges over multiple types of environments. And then we have had 3 relatively small contracts that were simply proved to us that an ultra-short pulse laser can deliver the effect that you're talking about. One for the Marine Corps for counter ISR, basically counter drone. One for the Army for countering surface-to-air heat-seeking missiles, and then one for the Navy that we can't really talk about the specifics of that, but obviously the Navy has big platforms that they would like to defend. My priority since becoming CEO in November of 2024, it's all about demonstrating this capability in our battle lab at medium range to begin with and ultimately long range. So doing demonstrations, getting lasers into the battle lab by the middle of the year, integrating with a third-party laser platform that you'll see on the next slide, and then increasing the staffing around engineering and prototype development. What you're seeing on the right-hand side, those top right boxes are our first prototype boxes that we will be putting the laser into. The bottom is a rendering of what the final system will look like. And basically the way this will work is you'll have multiple of these types of boxes that you just connect together to create the laser that you then put into a larger enclosure to accomplish the mission. The cord system itself, it's all about the things that we don't do. We've been focused on the laser. They provide us all the software. It gives us the ability to understand how to integrate our laser into somebody else's system. This is obviously not the footprint we're looking for, but it has the things that we don't have, mainly in the form of the software. We've talked a little bit about our progress. You see the 3 contracts that we've had in the past. We recently added a 4th contract with Rochester. The thing to understand about those 4 contracts is the power of each one of those lasers gets higher as you move from left to right, and that trend is going to continue into future applications as well. We also expect to see spin-out capabilities in the field of biomedical research as well as advanced manufacturing. We expect these to be large addressable markets, $32 billion anticipated by 2033 for directed energy, $12 billion by 2032 for counter UAS. The one point I would make on this top left data point, the $32 billion, in my opinion, you don't really see that kind of number until someone solves the size, weight, and power problem that enables the DoD to start inserting this kind of capability into existing programs of record or awarding new programs of record where they're buying these things on an annual basis. So what that looks like from a practical standpoint is if we were to see our system deployed on a vehicle such as the DoD's Joint Light Tactical Vehicle, it's a little bit up in the air on how many of these things are going to be ultimately produced because of some changes by the recent administration. This model was put together assuming 40,000 vehicles. If you assume 5% penetration of that platform, it would imply 2,000 units to be produced. And this is the typical production ramp that you see for a DoD program of record. We're sort of assuming here that our price point is going to be about $1 million a copy, producing 250 units a year. Ultimately, the blue bars here, the production revenue, represents about $2 billion of revenue over time. The gray bars are the support and sustainment of those systems over time through about the 25th year. So the total opportunity for one program of record for one platform in this particular case could be as much as $4 billion. and the business is all about going and finding another one of those things and another one of these things and stacking these programs on top of each other over time for different applications and different platforms achieving different types of purposes. My last slide here is one little blurb on Golden Dome for America. So again, we believe a core pillar of Golden Dome is going to be taking out the eyes of the things that are staring at you at any altitude. And if you want to do that, the ultra-short pulse laser is really the only viable concept to make that happen. Because of our size, weight, and power advantage, because of the sub-second engagement time required to deliver the effect, because of our ability to operate across different wavelengths, because of the low average power, which means we have a very low thermal signature, meaning we're not going to stick out if an infrared camera is looking for our system. These are all things that combine together to really make an ultra-short pulse laser the ideal platform to use if you in this counter electro-optic pillar that we expect to see as part of Golden Dome. So that's my last slide. I will switch over to the Q&A and I will try to get through as many of these as I can. So will your company also be using steadily growing augmented reality technology within your current or future products? I'm not exactly sure about augmented reality, but if you go back to that slide with the overlapping fields of fire, it's pretty clear that we are going to have to be connected to a larger infrastructure. Again, we don't expect to be the single effector that is used to counter small drones. We expect to tie into a layered defense system where the software layer is going to be provided by another company that has the AI built in to know when a sensor tells it, hey, there are drones 4 kilometers out and they're coming from these different directions, start spinning up these lasers to be ready to counter those. The AI will then say, here's the drone I want you to shoot first. Here are the multiple lasers that I want you to fire against that particular drone. And then here's the next drone to go after that. The way to think about there's a question, any plans of uplisting? So the way to think about Applied Energetics in the traditional venture capital terminology, you should think of Applied Energetics as a post-Series A startup. We've raised about $30 million over the last 6 years. We have 25 to 30 employees. That's very typical of a defense tech, hard tech startup. We do plan to uplist to a national market sometime over the next 12 months or so. So we're working toward that. Let's see, what's the next question? What is the most significant near-term application or product that investors should be looking for? It's going to be the counter drone system. We are very, very close to having that technology moved into the battle lab to be able to do on-demand demonstrations of that platform. That again is one of my highest priorities. When a partner calls, when a customer calls, when a politician calls, and they say, hey, I want to come see this work against multiple targets, we have the ability on very short notice to be able to spin up the lasers to be able to do a multi-shot demonstration for that particular audience as quickly as possible. We have already taken our first multi-target test shots. We will be doing a lot more of those in volume once we get past a series of deadlines that we have set for July 1st. The biggest hurdle to commercialization, as I mentioned, we have been focused on the laser source itself, but we have to get to a full system. So we will likely partner with a third party who will produce the gimbal that sits on top to do beam delivery. We will likely partner with some outside parties as well as doing some of our own software development. So right now it's about integration, but the laser itself is very, very close to being ready. We're very excited about where we are. I can tell you that the energy level of my team is at the highest level I've seen it since I've been here, and I've been here for about 3 years. The last question is, who is your competition? So there is no competition for ultra-short pulse lasers. There have been 3 contracts awarded by DoD for the use of ultra-short pulse lasers as an effector to defeat targets on a battlefield, and we've won all 3 of those. The competition has been for budget. And if you look at the size of our contracts, they haven't been that significant. That's why we are taking more of a defense product approach to this. We're not going to wait for the DoD to do this and hold our hand out, waiting for them to give us the next round of capital. We are going to take control of our own destiny, like we've been doing, raising outside capital to develop the product, to produce it as a system that we can sell on commercial terms. The continuous wave laser guys, they are the ones who have cornered all of the DoD market for directed energy. We want to change that, and the way we're going to change that is by producing a system that is ready to go and ready to be demonstrated and ready to be bought. And with that, I'll thank you for your time. I appreciate it. And certainly if you have any follow-up questions, you can go to our website and submit questions through either our investor relations contact or through the info email address.